All right, we're going to get the stream started in just a minute. I'm getting the chat all set up and ready to go. As soon as Twitch decides to cooperate with me here. Friday, the 28th. Apologies if you're watching this after the fact. It's going to take me probably a half a minute or so to get everything set up and started. So while this is figuring itself out, let me talk a little bit about why I wanted to jump on today and do a short live streaming session. So we're coming to the end of the new material for our first exam. So next week in our course is going to be a week dedicated to an exam that looks back on all of the material that we've done so far this semester. So that includes basic notions of sets and subsets. That was the first week. Venn diagrams and operations on sets, unions, intersections, complements, all of that wonderful stuff, including analysis of applied survey problems. That was our second week. And then also the logical reasoning and propositional logic stuff that we've done just in this past week. So we've done a lot so far, and I just want to, I guess, take another half an hour here at the end of this week to talk a little bit more about a couple things that we haven't really had a chance to do justice to yet. I want to get back into survey problems again a little bit more because I think it provides a good opportunity to do two things. First of all, I want to take the opportunity to remind us about how to work with notation for sets. So when we have a 3-set survey problem, we'll have 3 different sets that we have to analyze, and the information that we're given in the data for that survey comes to us in a format that suggests certain set operations, so unions, intersections, complements. So figuring out how that all works is really helpful to help us figure out how to negotiate a survey problem. But the second thing that I want to use this opportunity to do is to talk more about a topic that we're going to see again in a couple weeks. So I think the second week after the exam, we're going to talk about percentages quite a bit, and so that's a topic that I want to take some time for us to revisit as well. So while we're getting set up here, just give me 30 more seconds, and I'll sit back down and start our stream in just a moment. Make sure that the chat window is the right window here. Yes, okay, that one's looking good. All right. So let's get into it and talk about a 3-set survey problem this hour. Again, if you have questions, things you'd like to see me address in particular, if I leave something unclear, if I really make a mess out of a point that I'm trying to make, feel free to drop a question or a comment into either the Twitch chat, if you're watching on Twitch, that will show up in the video itself, or drop your question inside of our Slack site in the doctor's office channel. I'll be able to get it either way. So let's go back and pick up a survey problem for us to sink our teeth into. So let me get a snapshot. Or no, let me just handwrite this one. So here is a 3-set survey problem. In our last live stream, the survey problems that we've done up to until this point together have mostly been survey problems with 2 sets. So I want to have the opportunity to do one that has 3 in it, just to again reinforce the problem-solving strategy that we looked at the last time we talked survey problems. So for starters, let's suppose that we had a survey and that the survey was taken of a total of, let's see, what's my total in this survey? A total of 1,500. So a survey of 1,500 college students. And it asked them about various forms of, let's diplomatically call it risky behavior. We've just yesterday come out of a very public national hearing for the confirmation of a Supreme Court justice in which we heard quite a bit about risky behaviors among college students. So this seems like a kind of a timely survey topic for us to be thinking about. So here's some of the results that the survey found. So the survey asked about 3 different types of risky behavior. Drinking alcohol, and I assume in the survey this is drinking alcohol at all, which by itself is not necessarily risky. I suppose you could do a similar survey where you ask specific questions to try and get at particular forms of drinking, like binge drinking and so forth. But let's say drinking alcohol, just write that down. Smoking cigarettes, risky in a health sense, both individual health and also public health. Helps if I spell cigarettes correctly. And then the third is using illegal drugs. So say you survey 1,500 college students and you ask them whether they do these things. Just give me one moment.
Are you still talking on the phone?
I'm live with my students right now.
Oh, live. So, yeah, okay, then, yeah. It's just a little, yeah, if you are with a student, then you can. This is a narrative statement referencing contractual criteria. What is contractual criteria? I have told.
I assume in the contract there's a language about PTR. What are the evaluation criteria? It should be in section A of the contract.
Oh, okay. All right.
I'm sure it's nothing surprising, but
yeah,
that's what it's referring to. All right. So here are some of the results of the survey that are given in this problem. So 894 respondents in this survey reported drinking alcohol. 665 reported smoking cigarettes. 192 reported using illegal drugs. So as I'm beginning to think about the information, the data that's coming at us in this survey problem, each of these is telling me just one piece of the puzzle, right? Because one of the first things that you notice is that the numbers here, 894, 665, 192, those numbers add up to more than the total number in our survey. Right? 894 plus 665 plus 192. We have, if we add those numbers directly up, we have 1,751. And there's only 1,500 people in my survey. So what that tells me, as a consumer of this information, is that there must be some people represented here who are in more than one of these categories. There must be some respondent to the survey who both, for example, say uses alcohol and also smokes cigarettes, right? Otherwise, if we were counting everybody only once in these groups, then we would have to have had 1,751 people in our survey. So that's the first thing that I notice, is that these numbers don't add up. And when I'm thinking about survey problems, I do a lot of those little mental consistency checks just to see what's the story behind the numbers as we're beginning to think about them. So there must be some people that do more than one of these things, or responded that they do more than one of these things in the survey. And knowing how many are in those overlaps, those intersections, is going to be the key to us being able to take apart the rest of this problem. So sure enough, we do get more information. And again, this is all coming to us in the statement of the problem. I'm not doing any calculation yet to find out these numbers. So suppose that the number who both smoked cigarettes and drank alcohol is 424. 424 said that they do both alcohol and cigarettes. So sure enough, there are some respondents to the survey who are counted in both categories, and in both of those categories, in their overlap is 424. But then again, some of those who used alcohol and cigarettes may also use illegal drugs. So there may be more to say about those overlaps. Let's keep reading. So there are a number of people in the survey who said that they use both alcohol and illegal drugs. So that number from the survey is 114, both alcohol and drugs. And between cigarettes and drugs is also an overlap. And that overlap is 119. I'm going to write that over here. Both cigarettes and drugs. And again, you'll notice that there's a potential for somebody in this survey to be in all three of these overlaps also, right? That if I responded to the survey and said I do all three of these things, I would not have as a college student, but if I did, then I would be part of this 424 and this 114 and that 119. And we have information, again, given to us in the data reporting for this survey about that size. And that is, it tells us that there were 97 that responded all three. So let's suppose that I'm taking this survey and I'm a public health official, or maybe I'm somebody that works in a campus wellness center or some arm of student life in a university that wants to understand sort of what this means for the students on my campus and for implications to health and wellness on my campus. Then what I probably want to do is I want to understand just how many students are involved in risky behavior in general. So let me pose that as the question. So how many students? How many in this survey are engaged in one or more forms? In one or more of these behaviors. Right? And this is, I think, typical of a lot of study designs around public health kind of issues, that if there are a variety of different factors that can all, behaviors that can all impact health and wellness in certain ways, then sort of the biggest jump that you might be concerned about as a researcher is the jump from those people who do none of those things to those people who do some of those things. Right? And so being able to quantify that difference might be something that we're interested in this survey. So how many students in this survey are engaged in one or more of the behaviors that are listed? So we talk about survey problems within a chapter about sets, because sets are a really powerful tool that we can use to organize the information that's coming to us in this survey. And from the information that we have, it seems like there are three sets that we really care about, and all of those sets live inside of the universe. And the universe, which usually we call U, so I'll call it U here, this is the universe of all of the respondents to my survey. So all respondents. But within my universe that has all respondents in it, I've got three sets. And because these three sets can all in principle overlap one another, I'm going to sketch it as though they can do that. So I'll arrange my three sets in such a way that they form this generic Venn diagram, right? And then I'll label them. So I want to give each of these three sets a name that I can use to refer to it. My preference when I'm sketching Venn diagrams is to put those labels right sort of inside of the circle. I just break the circle and write the label there. That way we don't confuse the label of a set with an element of that set or with a cardinal count of the elements in that set. So that's just why I'm breaking these circles. You might choose to do a little differently. So the sets we're interested in are the set of respondents who said that they drank alcohol. Now, since we're bringing these sets into existence, we can call them whatever we want to. And so I'm going to choose to give them names that are meaningful, that will help me to more quickly understand what sets are what later on. So I'm going to call the set of respondents who drink alcohol, I'm going to call that A for alcohol. So this set right here, if I shade it in, so this set here is going to be the set of all my respondents who drink alcohol. How about smoking cigarettes? Let me call that set C. I'm going to set it in a different color here also, just to try and keep everything as straight as we can. So the set of respondents who said that they smoke cigarettes, let's call that set C. Maybe I'll put that set right here, and then let me color that in. If you're a colored pencil aficionado, you may actually find it useful to color in your sets when you're doing this kind of analysis. You don't have to, but it's going to help me to be able to quickly refer to sets in the rest of this video by their colors. Apologies to any of you who might have visual impairments that affect your color vision. And then last but not least, the set of respondents who said that they use illegal drugs. Highlight that in red. And let's call that set D. D for drugs. I'll shade that one in also. So here I have my three sets, and they're all set up as a Venn diagram, permitting for a maximum amount of overlap between those three sets. So what I ultimately want out of a survey problem is the same thing I want out of any Venn diagram that I draw. I want a diagram that's going to show every element of these sets exactly once. Right? At no place in a Venn diagram can I write the same element in two different regions. Because if I do, then I'm depicting it as being two different, as living in two different sets, right? Two different regions of my Venn diagram. So that's the ultimate goal, is I want to make sure that I'm writing every element only once. When the elements are respondents to my survey, I'm going to have to somehow fit 1,500 elements inside of this diagram. So rather than drawing them all out, like here's Bobby, and here's Bill, and here's Jill, and here's Julie, and so forth, what we usually do for a survey problem is we'll just write down a number, and that number is the cardinal number for that region that it lives in. So for example, so let's get started with this survey problem. We know that there are 1,500 respondents to this survey. Where should I put that number 1,500? Well, the answer is I probably don't want to put it in this diagram anywhere, because as soon as I put it somewhere, like let's suppose that I put it up here, 1,500. I'll put the number sign in front of this. So the cardinal number of the set U is 1,500. That's a true statement. But the problem with writing the number 1,500 here is that because I wrote it outside of these three circles, outside of these three sets A, C, and D, it makes it look like these 1,500 people do not belong to the alcohol, cigarettes, or drugs sets. Right? Because if they did, I would have to also list some of these people inside of here as well. And I can't list the same elements in more than one region of a Venn diagram. So I don't actually want to write the number 1,500 there. What I might do, and what I sometimes will do when I'm analyzing a survey problem for myself, is put that information somewhere that's going to try and mitigate my confusion. So maybe I'll kind of write 1,500 with a little arrow pointing to the U, just as a mental cue that if I'm thinking about how many people are in this whole rectangle that I've labeled U, there are 1,500 people there in total. So how do we avoid that quandary of listing people in more than one, listing elements in more than one place on a Venn diagram, having the same element belong to more than one region? How do we avoid that? Well, the way to avoid that is to strategically begin in the overlaps. In other words, I don't want to work a Venn diagram survey from the outside in. I want to work it from the inside out. So rather than first thinking about how many people are there out here, or here, or here, or even here, the first place I want to go is right to the bullseye, right in the center of the Venn diagram. That place where all three of my sets overlap is the place that I want to start. Because I know I have information already in my data for how many people there are in that biggest of overlaps. Then I just need to make sure, as I work my way out from that middle, that those people who are in smack in the middle are never getting double counted in any other region. But starting with the region that is the most specific in which they can be counted, then we know not to count them in any of the less specific, less restrictive regions as we march our way out. So I'm going to begin, sort of label this here. The first place I want to start is right here in the middle of my Venn diagram. So let me look in my information from the problem and ask, how do I know how many people are in that triple intersection? This is the intersection that we would call A intersect C intersect D. Do we have information in the problem that tells us how many people there are in that triple intersection? Yes, we do. It's right here. These are the 97 people who said, oh yeah, I do all three of those things. I drink alcohol and smoke cigarettes and I use illegal drugs. And so that means that I can write the number 97 here in that triple intersection, and that gets my ball rolling. That's the snowball that we're going to start rolling down the hill to analyze this survey problem. And just to tag back to notation, all three, so the set of respondents who said yes to all three of these things, would be those elements that belong simultaneously to the set A and C and D. If we were doing logical ands, we would use these upside down V's. But because these are set operations, instead of upside down V's, they're upside down U's. They're intersection symbols. So this is the intersection of all three of those sets. A intersect C intersect D. Okay, so we know now that there's 97 people in the triple intersection in the middle. My next job is to take a step outwards and look not at the triple intersection, but at the double intersections. Those people who do two of these behaviors, but not three, because we've already counted the people who've done three. So how many people do just two of these behaviors? Well, that depends on which two we ask about. Let me start by asking about alcohol and cigarettes. So the drinkers and smokers who do not use illegal drugs. So how many people are there in the intersection of A with C, but who are not part of this 97 who do all three, alcohol, cigarettes, and drugs? How many just do alcohol and cigarettes? Well, we have some information. We know that 424 say that they are both drinkers and smokers. But that only means that there's 424 people in the entire overlap of A and C. And so this 424 also includes the 97 who say that they do all three. So if I don't want to double count anybody, then I need to make sure that the number that I put here is not 424, because some of those people are also here. But I need to take away the 97 who do all three from the 424 who do both alcohol and cigarettes, to figure out how many people do just those two of the three things. So how many people belong in region 2 that I've listed here? 424 minus 97. 327. Don't be shy to use a calculator for this arithmetic. I'm sure you already are, especially online students watching this, but some mental math is good. All mental math is unnecessary. So I put 327 people here, and we can check. Again, we have these consistency checks as we go along. If I add together this 327 who drink and smoke but don't do drugs, together with this 97 who do all three of those things, I get the 424 people who said in the survey that they both drank alcohol and smoked cigarettes. And so we're doing good. Right? We have 327 and 97 makes 424. Then I just need to do the same thing with the other double intersections. How about this one? In this intersection here are the people who drink alcohol and use illegal drugs, but they don't smoke cigarettes. And we know that the alcohol and drugs combination has 114 people, but that 114 also includes the 97 who do all three. So to figure out how many do just two out of the three, we have to take those 97 away, just as we did in the last example. So from my 114, I'm going to take away 97. And I find out that there's 17 people in my survey who drink alcohol and use illegal drugs, but who don't smoke cigarettes, at least. So there's 17 in that double intersection. And then last but not least, the remaining double intersection, so the fourth place that I'm going to go in my analysis is over here. These are the people who smoke cigarettes and use illegal drugs, but who don't drink alcohol. Well, we know in the survey that there were 119 people that said that they were part of both C and D, cigarettes and drugs. But 97 of those people are in the all three category, so we'll take those 97 away. 119 minus 97, and that'll be how many people do just cigarettes and drugs. 22. So there's 22 people in our final double intersection here. And again, if you're worried, you can always go back through and add some stuff up. and just verify. 97 and 22, that should be my cigarettes and drugs people. That's 119, and that's what we had, and so forth. So now we're not double counting anybody in this survey who's engaged in 2 or 3 of the behaviors. What we need to now do is account for the people who do just one of these behaviors. Just the drinking alcohol people, just the smokers, and then just the illegal drug users. How do we get those people? Well, again, going back to our survey data, we know, for example, if we take alcohol, we know that there's 894 people in the survey who said that they drank alcohol. But we've already accounted for a great number of them. We've accounted for the 327 who do just alcohol and cigarettes, the 17 who do just alcohol and illegal drugs, and 97 of them who do all 3. And so the people that are left over, who are people who only drink and don't smoke or use drugs, they have to make up the rest of this 894. So to figure that out, I just have to take away from this 894 everybody who has been counted as part of the cigarettes group also, as part of the drugs group also, and as part of the triple intersection. So I kind of have to do 3 subtractions in order to make this work. I need to subtract 894 minus 327 minus 97 minus 17. So I have to get all of those things. Let me try and sneak this in here. There we go. So in total, the number of people in this survey who only drink alcohol and don't do the other 2 of these risky behaviors, there's 453 of them. So that's what I'll put in this part of my Venn diagram. And again, consistency check. If we added together this 453, this 327, 97, and 17, I add all of them together, those should account for all of my alcohol drinkers. And sure enough, when I add those numbers together, I get 894. So that means that we're on the right track. And that was the 5th region that we figured out. So let me get that little label in here, just in case you look back at this picture later. As you might expect, then the 6th place will go is the people who only smoke cigarettes, but who don't drink alcohol or use illegal drugs. We know that there's 665 people that are in this whole green circle C, but that 327 plus 97 plus 22 of them have already been accounted for as doing 2 or 3 of these risky behaviors. So how many people only smoke cigarettes? We'll take the 665 and take away those 3 again, 327, 97, and 22. So in the survey, there are 219 people that only smoke cigarettes. And then last but not least, we'll do the same thing for the illegal drugs category. How many people just do illegal drugs but don't smoke or drink? Well, there's 192 people in the survey that said that they do illegal drugs, and these of them have already been accounted for. So I just have to subtract, take away from 192 all of these people that we've already accounted for in other ways. So in my drugs only category, I'm going to have 192 minus 97 minus 17 minus 22, 56. So there's 56 people that are only illegal drug users and they don't smoke or drink. And that completes my single users. So this was the 7th place that I went in the Venn diagram. So we have enough information at this point to be able to answer the question that I started with. If I'm the wellness center director on campus and I want to know how many students in this survey are engaged in 1 or more of these risky behaviors, now I have all the information I need to answer that question because I've labeled all the regions that are inside the union of A, C, and D. Right. So another way to think about what set this is talking about, 1 or more, that's talking about the union. A, union C, union D. So I'm going to belong to that set if I drink alcohol or smoke cigarettes or use illegal drugs or do any combination of those things as long as I'm doing 1 or more of them. Right? So that union is all 3 of these circles put together. And the real power of a Venn diagram is because every respondent appears in only one of these regions, we're no longer double counting anybody. So to figure out how many people there are in the union, These regions are what are called disjoint. They don't have any elements in common. All I have to do is add together the cardinal numbers of those sets. So 453 plus 327 plus 219 plus 17 plus 97 plus 22 plus 56. I'm running off the screen a little bit here. But hopefully you can kind of see that down there at the bottom. 1,191. So what that tells me then is that that's the cardinal number of this union. That's how many students in this survey were engaged in one or more of these risky behaviors. 1,191. And again, we could only figure that out because our process of labeling these regions ensured specifically that no respondent to this survey will appear in more than one region of the Venn diagram. This also, of course, will let us label the last region, which I didn't ask about here, but which we might as well. How many respondents to this survey did none of these risky behaviors? So where are my straight-laced, straight-edged, don't smoke, don't drink, don't do drugs kind of people? So to figure that out, now is when we can use this piece of information about my universe. I had 1,500 respondents to my survey, and I know now that the union of A, C, and D accounts for 1,191 of them. So the final step is to label the outside as being the 1,500 people in the survey minus the 1,191 who are inside one or more of my circles. That's 309, and therefore I had 309 people in my survey who said, yeah, I don't do any of those things. I don't smoke, I don't drink, I don't use drugs. And every survey problem, strategy, the form, always boils down to this process that we just did. The best strategy is to take the information that you have and begin in the overlaps. So start with the most restrictive category that you can find. In this case, it was the people who responded, yeah, I do all three of those things. Label the innermost intersection. And then, by taking away, by using subtraction, work your way outwards to the double overlaps, and then to the single overlaps, and then finally to the outside, those people in the universe who are in none of these three sets. Once you have this diagram labeled, with all of its regions being disjoint, right, no person is counted in more than one place, then any question that anyone can ask you about this survey, you can answer just by adding up regions inside of this Venn diagram. So any questions about this problem, this overall strategy, anything else you'd like to clarify? I want to make one more point about percentages as we're wrapping up. But anything else that I've left unsaid that you'd like to hear more about, drop a question in Slack or in the stream chat. And I want to close by making a point about percents. Because it's the case that most survey data that gets reported in the media, in academic studies, and so forth, most of them actually don't list numbers of respondents. Because very often you get weird numbers of respondents, like 2,605 people responded to this survey. Or maybe the number is so large that it's impractical to think about numbers that are of that magnitude. So very often you'll get information where you don't necessarily know how many people were surveyed. And if you don't know how many people were surveyed, and we still want some information about all of this kind of stuff, what will usually happen is that the information will be presented to you as percentages. So let's suppose that we did it that way. So let's suppose that 72% of respondents said that they drank alcohol. 41% said that they smoked cigarettes. Maybe 15% say that they use illegal drugs. And then let me make up some numbers for these other overlaps as well. Both alcohol and cigarettes, let's say that that's 30%. And both alcohol and drugs, let's say that that's 20%. And then both cigarettes and drugs, 12%. And then in the survey, the percent that did all three was 4%, or something like that. So what we have is a bunch of percentages. Rather than numbers, we have percentages. We're going to talk more about this in a couple weeks in our course, but a percentage is an example of a ratio. A ratio is a comparison. So when we say 72%, what we're really doing is setting up a part to whole comparison. We're comparing 72 of something to 100 of that thing. Right? So it would be like saying, in a room full of 100 respondents, 72 of them said that they drink alcohol. But it would also be the same as saying in a room full of 1,000 respondents that 720 of them drink alcohol. Or in a room full of 10 million respondents, 7.2 million of them drink alcohol. Right? So the percentage, 72%, captures the comparison of the smaller part to the bigger whole, right? Which only depends on the relative sizes of the part and the whole to one another, and doesn't depend on their absolute sizes. And the fact that it doesn't depend on the absolute size is actually a real benefit if we're analyzing percentages in a survey problem. Because what we can do is we can decide how many people were in the survey. As soon as I decide how many people were in the survey, then I can turn all of my percentages back into raw numbers, into amounts. And then it's just like any other survey problem. So the key to decoding percentages in a survey problem is you can choose the number of respondents. Because that's going to be the size of the whole to which the percentages are each a comparison. And if I choose this conveniently, then turning the percentages into numbers is super simple. And because percents are, by their very name, they're comparisons to 100, cent being the prefix for 100, choosing the number of respondents to be 100, you could also think of it as 100% of the survey. Right? What that does for me is it then means that my percentages that I had in the rest of the problem can just be transformed into numbers. I can just wipe out the percent signs. So out of my 100 people, 72 of them said I drink alcohol. 41 of them said that I smoke cigarettes. 15 of them said drugs. 30 said alcohol and cigarettes. 20 said alcohol and drugs. 12 said cigarettes and drugs. And 4 of them said all three. So as soon as I set 100 as the size of my universe, all my percentages can just instantly transform into numbers. You can just erase that pesky percent sign. The only time that we might not want to use 100 is if our percentages were expressed using some decimal places. So if I had like 12.5%, then I might want to scale up my size to 1,000 instead of 100 so that I can have whole numbers of respondents at the end of the day. But now, if I again go through this rest of the survey problem, I'm going to kind of do it quickly here because we're out of time in our stream today. I got to go teach my other class. But again, let's walk through the process. Start in the overlappiest of overlaps, which is here in the middle of my diagram, the people who said that they do all three of these behaviors. There's 4 of them. Now start to work my way out. This 4 people who said all 3 are part of the 30 who said that they do both alcohol and cigarettes. So in order not to double count them, I will take away that 4 from the 30 and get 26 people in this region. This 4 is also part of the alcohol and drugs contingent. That's 20 people. And so if I take the 4 away from the 20, I'll have 16 that reside in this double overlap. This 4 is also part of the cigarettes and drugs category, which has 12 people in it. If I take those 12 away from this 4, I'll have 8 that are a part of that double overlap. Finally, the alcohol category has 72 people total, of which I've accounted for 46. So 46 taken away from 72 will give me the alcohol-only crowd. What did I say, 72 minus 46? Again, my mental math is also not something I'm going to count on right now. So there's 26. And again, double check that all 4 of these numbers add up to 72. How about for cigarettes? Well, for cigarettes, I've accounted already for 38 respondents. There's 41 total that said that they smoke cigarettes. That must mean that I'm missing 3 that are in the only cigarettes category. Finally, my illegal drug users. Okay, so I've got a problem here. So my data is actually not correct. It's not sustainable the way that it is, right? Because I've already accounted for 28 illegal drug users, but I said there were only 15. in the data. Obviously, you can't do this with real data, but since I was making up data out of a hat, I'm just going to take the liberty of going back and saying, let's assume that I'd said that there were 30 illegal drug users. So if there's 30 and we've accounted for 28 here, then that must mean that we're missing 2. So there's 2 who are only illegal drug users. And now if I add up everybody that's in all of this union, we'll figure out how many people are in this survey are engaged in at least one of these behaviors. 26, 26, 3, 16, 4, 8, 2, 85. So if those were my percentages in my survey, then there's 85 out of my 100 people who said that they do at least one of these behaviors. That would therefore mean that there are 15 people, the leftovers from 85 to 100, that don't do any of these risky behaviors. And then the trick is, if we want to report our answers as percentages, because the original data was in percentages, all we have to do is remember that all of these numbers are now in reference to 100, and therefore if I want to express them as percentages, all I have to do is put the percent signs back. So we took the percent signs away for a period of time so we could deal with just numbers, and we were able to do that because we chose 100 as our referent. But then that means that at the end we can put the percent signs back on. And so if I'm, again, my campus wellness center director, I'll be able to say, based on this survey, that 85% of respondents on my campus are engaged in one or more of these risky behaviors. And I should be very careful here to say 85% of the people who responded to this survey. Whether that truly represents 85% of the student body, that's a question about sampling, which we're going to talk about in the last unit of our course. But just being able to play with these percentages, turn them back into raw numbers by choosing the number of respondents to be 100, then do the survey problem like usual and reintroduce the percent signs at the end. That's a really, I think, straightforward strategy for what to do in a survey problem when you're given percentages rather than numbers. I hope today's live stream was valuable. Don't forget we have a quiz due this weekend, a revision also if you're submitting a revision. I've pushed those due dates back to Sunday rather than Saturday because the quiz was posted a day late this week. And then as we roll into next week will be an exam week. So rather than having a streaming session like this where we talk about new stuff, next week's streaming sessions are going to be dedicated to exam review. So please do try and make it so that the session can be driven by your questions and the things that you most want to talk about. But even if you're not there, I'll be picking some review problems, talking through them. We're going to do it early next week so that you have plenty of time to be working on the exam. I'll hope to see you then, and hope you have a good weekend.